Welcome to aminacademy.com. In astronomy, let us discuss about Earth and sky. Earth is the third planet from the Sun and the only astronomical object known to harbor life. That means mankind can easily make a life in this planet only. This is enabled by Earth being a water world. The only one is the solar system sustaining liquid surface water. Almost all of the Earth water is contained in its global ocean, covering 70.8% of Earth's crust. The remaining 29.2% of the crust is land, most of which is located in the form of continental land masses within one hemisphere, Earth's land hemisphere. Most of the Earth's land is somewhat humid and covered by vegetation, while large sheets of ice at Earth's polar deserts retain more water than Earth's groundwater, lakes, rivers, and atmospheric water combined. Earth's crust consists of slowly moving tectonic plates which interact to produce mountain ranges, volcanoes, and earthquakes. Earth has a liquid outer core that generates a magnetosphere capable of deflecting most of the destructive solar winds and cosmic radiations. Now, what about the sky? The sky is an unobstructed view upward from the surface of the Earth. It includes the atmosphere and outer space. It may also be considered a place between the ground and outer space, thus distinct from outer space. In other field of astronomy, the sky is also called a celestial sphere. This is an abstract sphere concentric to the Earth on which the sun, moon, planets and stars appears to be drifting. The celestial sphere is conventionally divided into designated areas called constellations. In order to create an accurate map, a map maker needs a way to uniquely and simply identify the location of all the major features on the map, such as the cities or natural landmarks. Similarly, astronomical map makers need a way to uniquely and simply identify the location of stars, galaxies, and other celestial objects. On Earth maps, we divide the surface of Earth into a grid, and each location on what grid can easily be found using its latitude and longitude coordinates. Astronomers have a similar system for objects on the sky. Learning about this can help us to understand the apparent motion of the object in the sky from various places on Earth. Now, locating places on Earth. At most any point on Earth, the four directions north, south, east, and west are well defined, despite the fact that our planet is round rather than flat. The only exemptions are exactly at the north and south poles, where the direction of east and west are ambiguous because points exactly at the poles do not turn. We must define the circles on the sphere that play the same role as the rectangular grid that you see on city maps. Earth's axis of rotation defines the location of the north and south poles and of its equator halfway between. Two other directions are also defined by Earth's motions. East is the direction towards which Earth rotates. The west is its opposite. At almost any point on Earth, the four directions that already told, north, south, east and west, are well defined. We can use these ideas to define a system of coordinates attached to our planet, such as system like the layout of streets and avenues in some cities. Helps us to find where or want to go. That means the GPRS is useful nowadays. Where you want to go, where how to locate our place to reach is easy now. Coordinates on a sphere, however, are a little more complicated than those on a flat surface. We must define circles on the sphere that play the same role as the rectangular grid that you see on city maps. A great circle is any circle on the surface of the sphere whose center is at the center of the sphere. That's called a great circle. For example, Earth's equator is a great circle on Earth's surface halfway between north and south poles. We can also imagine a series of great circles that pass through both the north and south poles. Each of the circles is called meridian. They are each perpendicular to the equator, crossing it at right angles. Look at here. This figure says the things. Here, this is a prime meridian of longitude axis. Here, this is a latitude axis. Like here, this is the equator. This is a meridian. From this equator and meridian, we can locate in particular places in longitude and latitude axis. We use latitude and longitude to find the cities like, for example, Washington, D.C. on a globe. Latitude is the number of degrees north or south of the equator. That is called a latitude. Here, these lines are latitudes. And the same way, and longitude is the number of degrees east or west of the prime meridian. Washington DC is coordinates are 38 degrees north, 77 degree west. That is here 38 degrees north, 38 degrees north and 77 degrees west. So we located here. Why Greenwich, you might ask? That means what about the Greenwich, the place? Every country wanted 0-degree longitude to pass through its own capital. Greenwich, the site of the Old Royal Observatory, was selected because it was between continental Europe and the United States. So it is somewhat easier places than others. And because it was the site for much the development of the method of to measure the longitude at sea. Longitude are measured either to the east or to the west of the Greenwich meridian from 0 to 180 degrees. Longitude at the sea, the longitudes are measured either to the east or west of the Greenwich meridian. As an example, the longitude of the Clock House benchmark of US Naval Observatory in Washington, D.C. is 76.0066 degrees west. This is a longitude measurement. Here, the Royal Observatory in Greenwich, England. This is a Royal Observatory. Locating like that, longitude and latitudes are measured for a particular places in terms of degrees. Now, next is locating places in sky. Position in the sky are measured in a way that is very similar to the way we measure position on the surface of Earth. Instead of latitude and longitude, however, astronomers use coordinates called declination and right ascension to denote position of the object in the sky. It is often convenient to make use of the fictitious celestial sphere. We saw the observing the sky in previous videos also. that the sky appears to rotate about points above the north and south poles of Earth. Points in the sky called the north celestial pole and the south celestial pole. Halfway between celestial poles and thus 90 degrees from each pole is a celestial equator, a great circle on the celestial sphere that is in the same plane as the Earth's equator. We can use these markers in the sky to set up a system of celestial coordinates. What is declination? Declination on the celestial sphere is measured the same way that latitude is measured on the sphere of Earth. From the celestial equator towards the north, that is positive, or south as negative. So Polaris, the star, the Polaris, the star near the north celestial pole has a declination of almost 90 degrees. What is right ascension? Right ascension RA is like a longitude, except that instead of Greenwich, the arbitrarily chosen point where we start counting is the vernal equinox, a point in the sky where the ecliptic, that is the sun's path, crosses the celestial equator. Thus, for example, the 360 degree of RA that it takes to go once around the celestial sphere can just as well be set equal to 24 hours. Then each 15 degree of arc is equal to 1 hour of time. For example, the approximate celestial coordinates of the bright star Capella or RA is 5 hours, that is 75 degrees, and the declination is plus 50 degrees. Now, next, one way to visualize these circles in the sky is to imagine Earth as a transparent sphere with the terrestrial coordinates, latitude and longitude, painted on it with the dark point. Imagine the celestial sphere around us as a giant ball, painted white on the inside. Then imagine yourself at the center of Earth with a bright light bulb in the middle. What happened? Looking out through its transparent surface to the sky, the terrestrial poles, equator and meridians will be projected as a dark shadows on the celestial sphere, giving us the system of coordinates in the sky. The turning Earth. Why do many stars rise and set each night? What's the reason? Why, in other words, does the night sky seem to turn? We have seen that the apparent rotation of the celestial sphere could be surrounded our Earth by a daily rotation of the sky around the stationary Earth or by the rotation of Earth itself. So far we discussed and read about the sky and Earth and its longitude and latitude and location of a particular place in terms of longitude and latitude. We have done. Please subscribe our YouTube channel.